only 19 slides, so that's going to fly by. So this semester we have talked about, in case you didn't notice, sensory systems. Right? Is everybody aware of that? Great, thanks for the head nods. So we've talked about sensory systems. We've primarily talked about them in isolation. We talked about a little bit of sort of crosstalk within each domain. We've talked a little bit about, taste adaptation and things like that. What I'd like to do now is talk about things that are going across one sensory system to the other. Okay? So we want to think about that architecture, multisensory processing. Think about some of the mechanisms. We're going to talk about synesthesia kind of at the end of this. I hope some of you find that entertaining. And we'll talk about the utility of synesthesia. And we may even visit one of the greatest news sites of all time, The Onion. You guys still read The Onion? Is that a thing people read? Okay, like 2 of you read The Onion. The rest of you think that's like real news probably. You gotta watch it. No, nobody's biting on that. That's fine. Let's talk a little bit about modular processing, right? So we want to think about sort of different approaches to processing sensory information. And one of these is modular processing. And there's some cool features of modular processing that are going to be helpful. Like if we were to design all of our sensory systems to do modular processing, we're going to do that. If we were going to do that, what would be the things that would be an advantage of modular processing? Okay. One great advantage is we can optimize that particular module for a specific function. Okay? We're not worried about making a module or making a sensory system that can do many different things. All we have to do, Ashton, is we have to make one module that does one awesome thing. We have to make your visual system that just does vision. We've got your auditory system that just does auditory, right? How many of you have a spatula just for pancakes? Oh, just me. So I've got a spatula just for pancakes, and then I have a spatula for other things, right? Like eggs. You have to have a spatula? No. But you could, right? I mean, how many of you, does anybody bake? Does anybody cook? All right. So Monica, you have to have special utensils that only do one thing sometimes, right? True, right? So do you have a spring-form pan? You're missing out, because what you can do with a spring-form pan is make cheesecake, which is probably the most important thing you should ever learn to make, is cheesecake. So if you don't know how to make a cheesecake, Monica, you're welcome. You're excused absence. You can leave class and make it, as long as you bring it back to us. Good pass. That's fine. So you have a spring-form pan. Let's imagine you do. I have one just for cheesecakes. I don't make anything else in it because it's not suited for anything else. It's only suited for cheesecakes. Now what happens if I lose my spring-form pan? I can no longer make cheesecakes, but I can still make other things because I have other pans, right? Okay, so that's fine. So we can operate maximum speed and efficiency. We're not going to be compromising things because we're not trying to do several functions, right? It's all optimized on one thing, okay? And one thing only. Anybody a baseball fan? Okay, so in baseball, you can be something called a left-handed specialist, right? This is one guy, and all he does is he will go out and throw somewhere between 3 and 6 pitches in a game to a left-handed batter who is quite good, and then he will go sit down. And you can make a fair amount of money doing that, right? That's not such a bad job, right? Like once every game or two, you kind of shake your arm a little, and then you throw a few pitches. You're specialized. That's all you're doing. They're not going to ask you to swing the bat. They're not going to ask you to catch a ball. They're not even going to ask you to throw a pitch to a right-handed batter, right? Just to a left-handed batter, right? So a few years ago, lots of folks were making their money if they could throw pitches to Barry Bonds. Anybody remember Barry Bonds, right? He was a phenomenal power-hitting lefty, right? And so you could make a career out of preventing Barry Bonds from hitting home runs. And there were people in the National League West who would have paid you a small fortune to be able to do that. So definitely not going to be doing multiple functions at once if we're talking about modular processing. The other cool thing is errors remain confined to that one function and they're not going to be propagated amongst other systems. If you have an error in your visual system, that does not necessarily mean you have auditory difficulties as well, right? We're going to keep this isolated to the visual system. If your left-handed specialist blows out his elbow, you've still got starters and other relievers, right? Okay, so the rest of your team can continue. We're not even talking about the people, on offense who are actually trying to hit the ball, right? What's also cool about this is you can make new functions simply by creating and adding these new modules, right? So you kind of tack on new modules. And this is really how our sensory systems developed. They started out as chemical senses. If you think about life started in the ocean, right, Oliver? So it's kind of just floating around in water. Vision and hearing don't do you much good, but something like taste would be helpful because you're going to be catching these molecules that are dissolved in the water, right? And taste or smell would be very similar. We don't think about smell in the ocean, but it's really still a chemical sense, right? We're picking up these dissolved molecules. If you think about like a molecule of blood, right? So you think about like, predators, for example. They always tell you like a shark can smell one drop of blood 10 million miles away or something. And it seems a little stupid, but the problem with that, Justin, is, as you know, that drop of blood actually has to make it to the shark, right, before he knows it's there. So it has to dissolve and pieces have to travel, right? So keep that in mind. So you can actually only sense a drop of blood that's right in your nose. Just from a very technical standpoint. I know, right? It makes you think like, oh, I used to be a Shark Week fan and now I'll never watch that again. Anybody ever watch Shark Week? Is that still a thing? I remember like the first Shark Week. I thought that was cool, and then now I don't know. All right, modular processing, that's kind of cool. Here you think about this, blue, we have vision, we've got somatosensory in yellow, auditory is kind of in this light blue, and we do have some multisensory integration areas where these guys overlap. Not a big deal. Why is it important that we're able to integrate things across sensory domains, right? In medicine, it's important because I don't know if you've ever looked at a natural object. These things exist all over the place. And they actually tend to be multisensory, right? How many of you have ever seen a bird? Okay. So you've seen a bird. That bird also makes noise, right? So you have sort of vision and auditory signals at the same time, right? You're not just wanting to see or hear things, you're wanting to integrate all of that together, right? And that's just one sort of simple example. What's been interesting about this is that, there's been a bunch of research on these multisensory processing, right? Typically how this works is they will simultaneously present stimuli in different sensory modalities, right? And if this is your approach, so if you can present a visual and an auditory stimulus at the same time, if these were processed independently, okay, presenting any one modality should not be affected by the presence of any other modality, right? So if vision and hearing are truly, completely, always separate, if I present a visual and an auditory stimulus to you at the same time, they should not interfere with each other, right? If they're constantly separate. Okay? But if there is some interaction somewhere, okay, then we might start to see some influence between these two different sensory modalities, right? For example, if you use a multisensory stimulus, it's actually been demonstrated that it can improve detectability, identifying the stimulus. You can even shift the location, perceived location of a stimulus this way. How many of you own a television? Yeah, how many of you have speakers on that television? Most televisions come with speakers, right? Anybody have some of those TVs that have like a sound bar on the bottom, right? That's kind of a thing, right? Are you guys familiar with that? How many of you have ever watched the news, for example? Anybody ever seen the news? It's a thing. It comes on all the time. Normally there's like one person in the middle talking, right, on your television. And where does his or her voice come from? You're watching this. Where's the voice coming from? Huh? No, nobody's going to guess. Why does no one want to guess? It's pretty obvious. There are only two possible answers here. And neither one are necessarily wrong. There's probably one that's more correct than the other. And your two possible choices, Justin, were the mouth or the speakers, right? I mean, that was it. That was it, guys. That's all you had to say, mouth or speakers. Speakers is 100% technically correct. The mouth is where you perceive the noise coming from, right? The sound. So, Oliver, you're watching, I don't know who your favorite newscaster is. Do you have a favorite newscaster? You don't? You should pick one. I don't know, right? I mean, maybe you're a, I don't know, maybe you're a Jake Tapper guy. Maybe you like Aaron Burnett. I'm just trying to pick some CNN folks. You guys don't watch CNN? Anybody that thought that was a good one? You watch it some?
I watch it.
Yeah. See, Wolf Blitzer, I don't know, maybe Anderson Cooper, Don Lemon if you stay up late. I don't know. So somebody there for everybody, right? So you're watching, you know, and you think the voice is coming from the mouth. In fact, it's really coming from the speaker, right? And so that multisensory presentation of a visual stimulus of someone speaking and sound coming from a different location makes you think, makes you perceive the voice coming from the mouth, right? Ashton, you never thought of this. That's pretty fascinating, isn't it? I know, right there. How many of you love ventriloquists? Nobody does. Don't raise your hand. Who was that guy for like 6 weeks who was popular that was a ventriloquist? And then he came to town recently because we always get people 6 years after they've been popular. What was his name? Yeah, that guy. That's the only ventriloquist I know. Did anybody go to that show when he was here? You can admit to it. We won't make fun of you. Ashton, go ahead and rate it. You didn't go. Probably too expensive, wasn't it? It's like, who wants to watch this guy? All right. So let's think about detection a little bit. Bimodal stimulus, what do we mean by bimodal? Two sensory modalities. Seems to speed up reaction time. Okay. So if I present you a visual and an auditory stimulus, you seem to be able to detect that faster than if I just present either one alone. Okay. Detectability, so whether or not you can determine if something is present, right? Okay. Seems to be higher if there's an auditory stimulus presented on the same side as a visual target. This simply is a graph showing you that, not a big deal, so don't worry too much. Basically what they do here is they're going to present a light or something to one side or the other. It's going to be difficult for you to see, so it's not going to be very bright, right? So it's not going to really, it's going to be low contrast. So you're not going to really be able to see, like, is it there, is it not there? And if they present that at the same time that they present an auditory stimulus on the same side, you're much easier to detect that it's there. It's much easier for you to do that, okay? What about identification? This is kind of interesting. Often identifying something can be sort of influence that perceptual quality, right? By a different sense. So for example, sound and touch. How many of you have ever rubbed your hands together? If you haven't, you should give it a try. It's something, right? It's kind of easy to do. You can practice that if you want. If you change the sound that's made while you are rubbing your hands together, it can actually change your perception of skin texture, right? So you kind of rub your hands together and it's like, oh, that's pretty smooth. And if you rub your hands together, it's like, then you're going to think, well, my hands are really rough. And then in fact, they may actually be the same texture. They just may be changing that sound. So that's why, how many of you work at a place that sells hand lotion? Yeah, Ashton, do you work somewhere that sells hand lotion?
I don't sell it, but I work at a jewelry store and we use it all the time to get jewelry.
Yeah, I'm always that's why I wear very little jewelry. Slightly more than I wear probably at any given moment, which I think most people are that way, right? That you own more than you wear. You probably don't wear everything you own at the same time. But I would constantly be afraid, like that's why I don't go bowling. I'm afraid my thumb will get stuck in the bowling ball. I don't know, is anybody else afraid of that? Yeah, Justin, right? I mean, it's like a thing, right? I mean, it can happen. So I just want to like stick my hand in a vat of olive oil first, and then I also am sort of weirded out by sticking my fingers in holes where other people have stuck their fingers. Other people's hands aren't that clean, right? And so you got to think like, I don't know. So that's something else against bowling. Unless you take your own ball, but you never know what they do to it back there, Oliver. So it goes back, disappears for a while, and then it comes back out. You just don't know what's happened to it. Just want to get one without any finger holes and just kind of.
Just go duck pin bowling.
Huh?
Just go duck pin bowling.
Duck pin bowling. I don't know that one.
Go watch it.
I don't know.
It's just bowling without the holes.
Really?
Perfect for you.
Yeah, that's fine then. I can do that. Is it like the same size ball?
Now they're smaller.
Oh. Let's give that a try. Is it outdoor?
No, it's indoor.
It's indoor?
It's like the same like bowling alley and everything.
There you go. I learned something today. I don't know that it was useful, but I learned it anyway. So, there you go. What about smell and color? How many of you love strawberry? Anybody hate strawberry? My brother's allergic to strawberry.
I am too.
Yeah, if it's natural strawberry, it just turns him red.
I
He's
break out in hives.
all over his face. It's pretty bad. What about liquid, right? So if you stick a little strawberry, in your liquid, right, that's fine. If you actually color it red, it will have a stronger sort of odor to you, right? So if you think about this, how many of you have ever read the ingredients of your foods? And how many of you realize all of the artificial colors that go in there? Yeah, artificial colors are pretty cheap. Fresh strawberries are not, right? And if somebody can dump some red food coloring in just a little bit of strawberry, and then you go like, wow, that really tasted like a whole lot of strawberry, I'm gonna buy that again. That's a lot cheaper than putting actual, real more strawberries in there, right? And really giving you more flavor and more strawberries. Constantly trying to cheat you, but now you know. Learning all kinds of great stuff. Sound and light, this is another kind of interesting one. Noise presented with light tends to be perceived as louder than the noise presented alone. So there you go, right? So instead of your parents like yelling at you all the time to turn down the radio or the stereo, right? Your parents ever get on to you about that? Like, turn down your music, it's too loud. It's a pretty standard thing. They should have just gone in there and like started flashing a light at you so that you thought the noise was too loud anyway and you turn it down on your own. That's a pretty good trick, right? So if you ever do like have kids, because you didn't listen to my advice, and they're making too much noise, just start hitting them with a really bright strobe light. You'll be fine. Also, light and touch. So tactile discrimination thresholds are lower during visual observation. So it's, you can actually like look at something and get a pretty good idea about it. All right, we already talked about a ventriloquist, so we can skip that slide. That was a fun thing. What do we want to think about here? There are some multisensory conversion zones in your brain. These are important. This is where we're getting all of that information together from these sort of sensory areas. A lot of this goes on in your parietal cortex, right? So there's a lot of information, a lot of sensory information being integrated in parietal cortex. Also out in the prefrontal cortex and a few subcortical areas. There's one in particular that's kind of interesting called the superior colliculus. This guy's really important for sort of orienting your head in response, or orienting your eyes in response to auditory stimulation. So it's a good visual motor, auditory sort of interaction area right there in the colliculus. It's kind of a fun thing. How many of you have ever heard a noise and you needed to like turn your eyes to take a look at it, right? Your superior colliculus was involved in that. It's kind of interesting that doesn't go all the way up to cortex. That takes a long time to go from like your eye or your ear all the way up to your cortex, right? It doesn't take as long to stop at one of those other locations before the cortex. Something as important as being able to turn around when you hear a noise behind you sounds like that is something we should do quickly, almost automatically, right? You don't really want to have to put a lot of extra processing steps involved into, hey, what was that growl behind me? Because if you spend too much time there, Marissa, you're eaten by a tiger. You gotta watch that. All right, we've already talked about some of this other stuff. However, not just in in those multisensory areas, we also have some multimodal work going on in areas that had previously only been considered as unimodal, or dealing with one sense, right? So even in primary visual cortex, there seems to be some sort of multimodal action going on, not a lot, but a little bit, right? And again, seems to be a good idea, right? And that seems to happen early. What else should we talk about? ERPs, I wouldn't worry too much about this. This is just a way to measure changes in the brain, in these different brain regions. Now, I think that the real debate is not whether or not we have sort of multimodal regions in the brain, right? But how early does that sensory information cross over, and how early does one sensory modality influence the other? I think that's the real debate, and I think that's what we're trying to figure out right now. Does that make sense to everybody? All right. Hey, who wants to talk about synesthesia? Anybody know what synesthesia is? Yeah, so most of the time people will give you this sort of exaggerated and incorrect thing. It's like, oh, it's like tasting colors and hearing, touch, I don't know, right? And it's like this sort of cross-modality sort of thing, which can happen. It's not the common sort of approach. But synesthesia in general is you have a single sensory modality, but it's going to sort of stimulate two or more experiences, right? Most of the time, the type of this is what we call like a sensory union. It's when folks will see sequences such as numbers, letters, or days perceived as sequences of colors. This is the most common type of synesthesia. And this is where I would like to step out and show you this phenomenally insightful article, again, from probably one of the most reputable of all news sources. And this one, Regan, is filed in Baltimore, apparently. There you go, right? So I think this is I can need that. So here we go. Report, sort of percent of Americans suffer from synesthesia. It's really interesting. As I said, many people who have synesthesia perceive letters or numbers in particular, like sequences, as blocks of color or bits of color. And so here, every time they have indicated a number, they've replaced that with a color swatch, which I think that was really brilliant on the folks who wrote this, because it shows like actually some deeper knowledge than your average person, right? About what is synesthesia, the most common form of synesthesia. So there you go. Right? I thought it was a fun article. Doesn't take long to read. I don't want to sign up for the newsletter.
I subscribe to this musician on YouTube, and he said he has synesthesia, and he perceives musical notes as having an individual color.
Yeah.
So like when he's playing bass, he sees like the colors on his fretboard, and he said that when he changes into different tunings other than standard, the colors can change in his head immediately.
That's pretty cool.
Yeah.
There you go. Yeah, I mean, I think that's that's very much in line with sort of the standard type of synesthesia, right? It's sequences. There are folks who look at calendars, and instead of seeing Monday, Tuesday, Wednesday, Thursday, Friday, they see, blocks of color for these sequences of the days, which would make your planning sort of difficult, right, if you are a person who has a planner. There were obviously a lot of doubts about synesthesia early on, right? Some folks were like, no, that's not a real thing. And they actually thought it was like a learned associative pairing while folks were learning to read. So, and that would make some sense, except the pairings are actually quite consistent. Brain imaging studies have demonstrated that, yeah, other sensory modality regions are being activated by this, right? And also, synesthesia tends to run in families, right? So there is some genetic contribution. Not exactly sure what that genetic contribution is specifically, but there does seem to be some genetic elements to that.
Is there any research that shows why people under psychedelics experience synesthesia sometimes?
Not familiar with that. That would be quite interesting to do. Unfortunately, I think, as most folks are aware, there's not as much research on psychedelics as those of us who are curious about that would like to see, right, Justin? Yeah, so there you go, right? Some good research ideas. There was a good bit of research with psychedelics a few decades ago, and then folks were like, no, we probably shouldn't do that anymore. And since then, it's been kind of hard for people to get drug research back up and running. But psychedelics are for those of you that aren't aware, are really an odd and unique set of drugs that don't operate in the same way as drugs like cocaine, for example, which is acts on a particular neurotransmitter system. Most psychedelics actually, as far as I know, there aren't really any psychedelics that are addictive. So folks take psychedelics and then most of the time they quit because they're kind of done with it. They kind of get bored, or occasionally they have the so-called bad trip that kind of freaked them out a little. They're like, I probably better not try that again. But it's not an addictive sort of process. If you think a lot of the sort of substances that certain religions use during their ceremonies, those are typically psychedelic drugs, and there are exactly 0 cases of someone becoming addicted during those ceremonies to a particular drug. So there you go, right? Psychedelics. I tell people LSD is probably one of the safest drugs you can use. And I know that's like, you don't think that, right? But let me explain this, Zoe, because, so with LSD, for example, you know, there's like a dosage you take to get you high, right? So you have that. You can take a 20,000 times higher dose and it not kill you. There's an amount of cocaine that you can take that will get you high. Have you ever tried to think about taking 20,000 times more cocaine than what it takes to get you high? I think that's called death, right? And so that's why I say LSD might be one of the safest drugs to take, right? So now you're coming over to my side on this, right? Also, the secondary sort of ramifications, again, there's no addiction potential, right? We're not worried really about any, you know, if you take other drugs, especially like cocaine or methamphetamines, you're worried about cardiovascular issues, right? And there are a lot of other problems involved. The real trouble with LSD is the things you might do while you're on LSD, right? And so if you're in sort of a safe environment, padded environment, where you can't like jump off of things or into traffic, you're probably okay. You know, if you're in the midst of some hallucinogenic trip and you're not aware of your surroundings, then obviously you can interact inappropriately with those surroundings, and that can cause you problems. But there you go, right? There is some risk, just so everybody's not like out there like, oh, right, let's go do LSD. There is some risk of this sort of, these like persistent hallucinations, right, that can come back as people go on flashbacks. They're usually not terribly pleasant. So that is sort of an issue. So there you go, right? Brief story of psychedelics. But there are all kinds of psychedelics out there, right? Peyote, for example. I mean, it's you know, used in certain cultures in a religious setting to no sort of stigma. There you go. So what about the origins of synesthesia? Where did this come from? Well, it seems to be that there are some connections between different parts of your cortex that handle different sort of sensory areas, right? For most folks, these connections like directly between the primary auditory, for example, and primary visual cortex might be weak or absent, but folks who they have synesthesia that would be a little stronger. Don't worry about that. The second thing you've got to think about is synesthesia even helpful, right? Because most things that have a genetic component, if they're actually detrimental, they'll disappear, right? Because people who have that particular genetic sequence will die, okay? Because they're not going to be as great at finding mates and breeding as someone who maybe has a more beneficial sort of genetic framework. There are occasional times where you kind of bounce things together, and there is some negative outcome if you get too much. If you get like 2 copies of a gene instead of 1 copy. But we could think about the utility of sickle cell anemia at some point, but we can think about that later. Which is actually kind of fast. Just in case you are curious about this, sickle cell anemia is not terribly cool, right? So you don't want that. However, if you live in a region of the world that has a high rate of mosquitoes that carry malaria, right? Having 1 copy of the sickle cell gene can be helpful, because malaria will specifically target the sickle cell-shaped red blood cells, and not your healthy red blood cells. You're not using those sickle cell-shaped red blood cells anyway, so who cares if malaria attacks those and it kills them, and then the malaria virus dies. So if you get 0 copies of the sickle cell gene, and you live in an area with a lot of malaria, you're probably going to get malaria and die. If you get 2 copies of the sickle cell gene, you're probably going to have sickle cell anemia, and you're probably going to die if you're in an area where there's not great health care, for example, right? In a place like the United States, that's not going to happen, but in some other parts of the world it might, and some other times it might have happened, years ago. But if you get 1 copy of the normal red blood cell gene and 1 copy of the sickle cell gene, not only are you not going to get sickle cell anemia, you're also never going to get malaria, right? So you have malaria resistance. And so if you sort of map this out on the map, which is kind of cool, you can look at a globe and map out where there's a high rate of malaria and where that's the same places where there's a high rate of sickle cell anemia, right? And the reason for that is there's an advantage to having like 1 copy of the sickle cell gene. So we could do the Punnett squares if you wanted, but we can skip that. Anybody excited by that story? Nobody? Moderately? So it's kind of this intersection between genetics and geography and pests. I mean, everybody loves mosquitoes, right? All right. So originally folks thought, well, people with synesthesia, I bet they're more creative, right? And they come up with all these awesome ideas that can help us survive and reproduce more. So there's some real problems with this. How do you measure creativity? Well, who knows? There are some ways that folks come up with these ideas about how they can measure creativity, Marissa. Doesn't really seem to be any difference between folks with synesthesia and control subjects. However, there has been some work that has demonstrated that folks with synesthesia might have a slightly better memory than folks without synesthesia. So having a better memory, just in case you don't realize this, is beneficial to survival, right? It's beneficial obviously to survival in the modern world because you can like remember where your car is, you can remember your boss's name, it'd be embarrassing if you don't, you can remember how to do your job. In the not so modern world, you can remember where there are great food locations, you can remember the last time a particular species attacked you and how to defend yourself, so having a better memory seems to be better. For you, there's a slight increase in memory for folks with synesthesia. Don't worry too much about this. What you can see is in every sort of testing phase, folks with synesthesia outperformed control subjects. All right, questions about multisensory integration?